I was finding with my Skywatcher Eq5 mount that occasionally I would lose power whenever I was halfway through shooting, and I decided to investigate, and it turned out that the actual power socket had begun to wear so much that it had become intermittent, and some nights it would just lose power straight away. So I took it upon myself to find a replacement connector, and I managed to identify exactly the right connector, and I was going to replace it. So here you can see I've taken the actual computer board, which the right ascension and declination motors plug into, and the handset plugs into, and I've unscrewed the actual case, and now I've set up, I've identified the different solder points, and now I'm literally going to use a vacuum pump to suck up the solder, which I'm just melting with the soldering iron at the moment. So you melt the solder and then you put the vacuum pump on and press the button, and it literally sucks the solder away from the joint, and eventually, if you've done this enough times, the joint becomes completely clear of solder and you're able to remove the component. Now, when I was doing this, I found that the copper track which holds the component in, because it's quite a high wear joint, it actually has the copper going through the printed circuit board, so it was really tough to get rid of all of the actual solder that was holding it in place. So I tried and tried again. Ideally I'd have probably used some solder removing braid, which would in effect use capillary action to suck up the solder. But in this case I was able to eventually melt the solder and just gently prise the component out of the socket, ready to be replaced. So you can see here it's actually loose already. I think one or two of the contacts, there were 3 in total, had already come loose, and it was just a question of positioning the component so that it would eventually allow me to remove it. Because I'd melted the solder on the board, the flux that was actually in that solder had spread across the printed circuit board, so I just used some alcohol to clean that off the board, because flux is quite corrosive, and long term I didn't want any damage to happen to the actual board. And it also cleaned up the joint, because as you're soldering it leaves an oxidized surface, so this just cleans the joint up a little bit. So at that point you saw that I held the soldering iron in place and wiggled the component, and it literally just fell straight out. So now I went through the process of cleaning up the actual holes where the new component would fit, just to make sure that it would take the component easily without bending any of the pins. And then I offered the new component up to the new socket and checked that all the pins were clean and in alignment, and eventually we managed to get it to fit. But again, because there was still some solder left in the joints, I ended up having to just melt some fresh solder onto the board so that I could try again just to clean out the actual soldered joints with the vacuum pump, and eventually I got it so that it was in a position where the new component could be held in position. So because I'm now starting to do some soldering with fresh solder, I wanted to make sure that I had the fume extractor on, so I've put that on the table now, and that's now taking away the fumes. And unfortunately, because I was doing this in the evening as well, the light was going, so I've now got a head torch on so that I can actually see the work that I'm doing on the actual board. So again, you can see I'm still cleaning out the holes here where the new component will fit. So at this point I'm just checking that all the joints are clean, and I can now offer the new component up to the printed circuit board, and I managed to get it to fit nicely this time. And when I put it back onto the table, the actual table itself was able to hold it in position, so that I was then able to resolder the joints with the new component this time. So you can see I've positioned it onto the table, and I'm just now melting the old solder to hold the new component in place. So that's what I'm doing right now. And then once I knew that it was in position and was lined up properly, I was able to get some fresh solder into the joints and reflow the joints. And you can see there, that's what I'm doing. I'm just flowing the first connector. Now the trick to this kind of soldering is to make sure you have a good hot iron, but not too hot that it will damage the board, the copper tracks, or any of the adjacent components. So I'm happy that the component's gone in, so now just a small amount of solder, and then making sure that it flows through capillary action going onto the printed circuit board. And you can see there's the component. It's just gone out of view. I'm just making sure that it's absolutely properly soldered. And now the third and final joint, just to make sure that it's all in place. And the key with soldering is to make sure you don't put too much solder on. You want just enough to make a really good electrical connection, hold the component in place. And now I was confident that everything had flowed properly, and there are a couple of bits that I just needed to top up because there wasn't quite enough solder, but you only need a tiny bit, just to really reinforce those joints so that the component won't move. Because it's a power socket and the power is going to be removed and reconnected, I didn't want it to come loose in any way. So now back with the alcohol and a cotton bud this time, just to really clean the joint, clean all of the flux off the printed circuit board, and any oxidation on there as well, so that it isn't going to corrode over time. And then I just checked that the component was firmly held in place and that I was confident that, that it was properly soldered. So the next step was to put the power switch back in, which just clips back into its socket. So then ran the power cable in so it was at the top corner. And then, because the actual case is quite heavily moulded to the actual components, even if the component was slightly out, it was going to be tricky to put it back together. So I just had to wiggle the case really, just to make sure that it would fit properly, and now it's a question of just putting the screws back in place. And there we go, so that was the final screw going in now. And we're ready to check that the unit looks like it did when we first started, before we started this work, and then we can give it a test on the actual mount itself. There we go, the finished item with the power socket replaced. So I then took this over to the Eq5 mount and plugged in the two axes motors, the right ascension and declination motors, then plugged in the handset, checked that the power is off at this point because I didn't want to plug it in. I wanted to check that the switch was functioning properly as well. So pop the plug in and power up. And success, it powers up, and you can see the mount is initializing and going through its startup checks. And I then wanted to make sure that the connection was absolutely perfect, so very gently moving the cable to make sure that it made a perfect connection.